Assalamu alaikum. This is the lecture series of category theory. So today I will explain isomorphism in category theory, the definition of isomorphism in category theory. Let's see be a category, any category. So any morphism from F from X to Y is an isomorphism if there exists an morphism G from Y to X such that G of X is equal to ID on X and F of G is equal to ID on Y. So what type of isomorphism? We can say X is isomorphic to Y if such a morphism F from X to Y and there exists G from Y to X such that this condition hold G of F, we will get ID on X and F of G. If we compose F of G, we will get ID on Y. So we can say X is isomorphic to Y. If the category of sets, so we can say this isomorphism and this is the bijection between X and Y. X and Y are bijectives. If the morphism in category of homotopy H top, so we can say H is homotopic to Y, X is homotopic to Y. If the morphism in top spaces, so we can say X is homeomorphic to Y. If the category of groups, so we can say the X is isomorphic to Y also. So this is the definition of isomorphism in category theory in general. If we take this isomorphism in another category means category of sets, so we can say the X is bijective to X and Y are bijective. Means there is a bijection between X and Y. Means the cardinality are same. If the category H top, if we are in the category of top and there exists a isomorphism, so we can say X is homotopic to Y. If in H if lie in top category, so we can say X is homeomorphic to Y. So this is the definition of isomorphism in category theory and apply on different categories of set. Okay, Allah Hafiz. I will explain next topic in next videos. Please share and subscribe my videos.